Okay, so this is the second FRQ that we are trying to solve of the mechanics one. So basically the question is, so first I want to show this question. So this is the question. So first I will request to you go and please try first, then look into the solution. So this is the first part of the question. And let me show you the second part of the question. This is the second part of the question. This is the cycle, by the way. So it is moving in this direction. So you can read the question, first attempt it, and just after that look into the solution. Thank you. Okay, so let's continue to the solution right now. So the question is right now, okay, show all the working of the each of the part of the question. Each part within the question may have not have the equal weightage of the question. Okay, so a car is moving along a straight horizontal road as shown in the figure 1, starting at the rest. So starting from a rest basically, so initial speed is, we are going to be use it afterwards. So the initial speed t is equal to 0, and when the time is 0, so the velocity is 0. So a car moves with a acceleration a that varies with the time according to the equation. So this is a acceleration, time varying acceleration that they already given it. So the p and the q all are positive constant. Positive direction is taken to be the right side. So this direction, they had taken it positive as per the question is, and the P and the Q constant are also positive. So now the thing is, it's the first question. So, okay, the figure 2, so this is the figure 2, they have shown the point basically that represent the car at a 2 instant when the time t1, t2, and each of the dot draws the arrows to represent the directions. Okay, and if the car of the acceleration at that time, if the acceleration is 0, either at the either time is equal to 0, so if the acceleration is 0 at a given point, you had to be show acceleration is 0, just write it. And if the acceleration is negative, you have to show to the left side, you have to show the arrow to the left side. And if the acceleration at a given point, it is the positive, so you have to show on the right side. So because as we had to just show the acceleration, the arrow of the acceleration only. So acceleration at that time. So time is known to us. T1 and the T2 are known to us. And even we know the expression for the acceleration. So just plug in the time into that. So let's check it out. If we plug in the time one into that one. So this is the acceleration one. So let me write it the acceleration one first. P minus qt, and we had to find out the acceleration at the t1. T1 point is known to us, so the p minus q, t1 is p plus q. So basically the q will cancel out, and simply it come out to be p minus p by 2. So it is, okay, so this is the time. If I, okay, so it is come out to be simply p by 2. So this is come out to be positive, means the p value is positive. So this is a positive value. So the arrow you had to be show at this point, the acceleration is towards this, towards the right, because the right side is positive. So now in the same way, so I'm going to find out the t2, acceleration of the t2. So expression is already aware of that one. So p minus q and dp by 2q, and qq will again cancel out basically, and it come out to be p minus qq will cancel out 3p by 2. And okay, so this come out to be negative p by 2. So this is the negative p by 2 that we have, the expression is. So now, so this is a negative because p is again the positive value. So obviously this is the expression is negative. So right now you have to show on the left side. So just show these arrows. On the t1, the acceleration is positive, and the t2 time the acceleration is negative. That the expression is pretty much simple, straightforward. Now we have the second one at the dot represented in the figure 3. So this is the figure 3, we have it. And now, okay, draw the arrow to represent the direction at any, if if any, the velocity at that time, and draw the arrows and the pointing out the direction of the velocity. So basically right now you had to do the same thing that you have above you had done for the acceleration. Now you have to do for the velocity. So let's move further to velocity. So we had to do the same expression. So same thing for the velocity, but right now you do not know about velocity expression. So we had to first find out the velocity expression. So this is the first part of the question. This is the acceleration is known to us. So how we can find out this one, please? Velocity, velocity from the acceleration. So you have to be just integrate the acceleration function with respect to the time. So we have to be just integrate. So just let's do the integration then. This is the pt minus qt square by 2. And you can put the c constant, but as we discussed it before, when the time is 0, this is constant value. So when the time is 0, the initial velocity is 0. So that constant is c value is 0, because when the time is 0, so you can plug into the function also. So p0 minus q, this is 0. So the c value is come out to be 0. So you need not be had to be worried about a constant. So now the final expression is the velocity expression that you will get this one. So it is just p t minus q t square by 2. So this is the velocity function that we have it. So, but the question haven't ended till now. So in the question they are asking the arrows. So basically, to positive or the negative values. For that one, I had to plug in the expression. So let's plug in the t1 value. So the t1 value is p by 2m. P by 2q, I think, sorry. Minus q p square by 2 is already there. So I had to write it, take care of that one. So this is 4q square. So I had done the squaring of them. So as I do that one, it come out to be p square by 2q minus q will 1q will cancel out, p square by 8. Please check it out the calculation from your side. So this is 4. So this is come out to be 3. 3p square by 8q. So this is the velocity that is seems to be positive to me. This is a positive. If it is positive, you have to be sure the velocity direction is to the right side. That you have it. And let's plug in the T2 also. Three P. cube by 2, this becomes 9p square plus 4q square. So if I had to calculate this way, 3p square by 2q minus 9p square by 8q square so basically you have to multiply with the 4. So this is 12, 12, 3. So 3p square by 8q, sorry. So this is again come out to be the same, but same direction, even the same direction. It is positive, this is also positive, so both the points. So the arrow you have to be show at this time. So this is the velocity direction is the towards the positive one. So this is the first part of the question that we have done it. So you haven't tried till now, please try it, and then let's move to the B part of the question is. In the P part, the expression of the answer in the P and the Q, P, capital P, capital, okay. So as appropriate, derive an equation for the car of the velocity as a function of the time, so that we already have done it. So basically the time expression, the velocity expression that we already done it. So this part that we already done it. So this is the this part basically. So let me show you again the answer. So this is the answer is. So let me show you the question, the second part of this. So derive the equation of the car of the velocity v as the function when the time is. So derive the expression of the car of maximum speed within the range of that one. So you had to be find out maximum. So basically you had to be find out the where the maximum. Maxima means that to find out any function, the maximum or minimum, what we do? The concept is how we can, let me just revise it slightly calculus. So you can skip that if you're already aware of that. So to find maxima or minima of any function, what we do over there is fx function, yeah, any of the function. So we just differentiate that one. So we find out the derivative. So something dy by dx, we put it equal to the 0 because this is some kind of the slope at a instant only. So if I had to be just goes little bit mathematics. So at these maximum minimum point to find out the slope, we draw the tangents. So the if the tangent is parallel to the x-axis, so basically there is no slope in this. Slope is steepness, how steep it is. So at this point, if you draw the basically if you draw the tangent to that line, so this is a horizontal line, there is no slope. It means that to find out the maximum minima, we derivative. This is a slope at that a given point only. This is the logic that we are using right now. So at this point, the slope is, you can say the slope or dy by dx, differentiation of that function. So if this function is y function that is depending over the x value, so we just differentiate and put it equal to the 0. So in the same way, dy by dx for this one is at this point is to find out maximum minimum, we just differentiate the function and we put it equal to the 0. So right now we are finding out the maximum velocity. So right now what we are trying to do is, we are trying to, as per the question, we have to find out the maximum velocity. To find out maximum velocity or maximum speed, I would say. So maximum speed of the function. So find out the speed. Speed doesn't, so I think they are asking for the speed. So you do not have to be worried about the direction. So you had to be just take the positive value that the maximum speed of that in that range. So basically the maximum one to find out the maximum. What one way to do that one is we have the velocity function as we discussed. You had to be, this is the velocity function. So this is pt minus qt square by 2. This is the velocity function to find out the maximum minima as we discussed. So you had to be differentiate this one. And that is acceleration only. When we differentiate the velocity function, this is acceleration only. And acceleration expression we already know that p minus qt. So, and this is the, I had to put that basically dy by dx, I had to put it to find out the maximum speed. I had to plug into the 0. So t is come out to be p by q. At this time, the the velocity is maximum, but they are asking the velocity. So maximum velocity has the maximum. To find out the velocity, obviously, so velocity expression is already known to us. So just plug in that time. So let me call it that time is where it is maximum. Let me write it Tm. So let me plug into the velocity function Tm to that expression. So add on the squaring of that one. So now p square by q so basically it is a p square. So the thing is that we can do right now is it is just the half. So basically p square by 2q. So this is the velocity when the at the tt. This is the maximum, I would say maximum velocity. This is the maximum velocity. To get the maximum velocity, we add the tm. So this is the maximum velocity expression. So this is the whole story. So if you want to take the screenshot, you can take it. And let's move to the next part of the question then. So please leave the comment if you have any of the doubt till now. So, okay, so I want to clarify. Okay, so till now, I think everything goes well. Okay, so that's good. Okay. Now what you had to do is on the same road that the car moving along on, a bicycle is moving with a constant. Just focus on this one. It is a constant velocity. It is moving with a constant velocity. This is the bike basically that they given it. So they haven't made it properly, but so this is the velocity in the positive x direction as they mentioned that one. Sketch a graph of a velocity, car velocity as the function of the t during the time interval indicated on the axis the observed from the ground. So this is observed from the ground. First you have to be draw the velocity time function when it is we are observed observation, we are doing the observation from the ground. So for that one we had to be look into that. Okay, so they have given the figure 4 here to draw that one. So let's try to draw it then. And in the second part, what they are expecting is in the frame axis, and this one, sketch the graph of the velocity as observed, when the observed from the frame of the bicycle. So another one is bicycle. So we will come to that point. So let me take it the velocity that is constant only, velocity of the bicycle. I will come to that point. First, let me try to solve the first part of that question is, okay. So this question, okay. So let's move further then. Hmm. So, okay. So you had to be draw the graph on this one. So the velocity time function. So we already know the velocity time function. So we already get that at the p by q, it is the maximum when the time is p by q. The velocity expression we already know that we just drive it. So this is the expression. The when the Tm is p by q at the p by q it is the have the maximum velocity p square by 2q. And if you look at this velocity expression carefully, so let me try to draw it. So let me show you some. Okay, so now if you know about quadratic expression somewhat, it is because the coefficient of the t square or x square, if the coefficient is negative, so you will get a downward parabola something. So you will get the shape like this, parabolic. It is a quadratic equation has a parabolic shape. So it will be like this something. And we know where the it had the maximum. So the maximum is point is, so the maximum point is when the t is equal to p by q, that at this time interval it had the maximum one, and that the t is equal to 0, the velocity expression is 0, that we already aware of that. And so if I go with the symmetry, so at the time this time interval is p by q. So at this time, so if at the again p by q interval, if I take it, this time is at the t2 basically, then 2p by q, it is have to be 0 again, velocity expression. If I try to relate all the things and the graph, at this it is 0 velocity function, at this somewhere the peak value you will get some peak value, at this again 0, so you will get some downward parabolic shape. And but okay, so if I do try to show you, okay, so you'll get 0, by the way, at this point it is a 0, and you have it is going to be cut somewhere here. So this cutting point you can find out by 3p by q, just plug into the expression. So 3p by q, so if I plug in that 3p by q, and if we are going to be plugging that function, just find it out, and its value is come out to be, so 3p by q, 2q, 2 is there, I think. No, 2 is not there. Okay. No, no, this is correct one. 3p by q, so you have to do it. Minus 6p square by q. So basically this is the velocity. So you will get the negative velocity, as you can see it also. So at this, the velocity expression is at the intersecting point. So you will get this point, please. So you can just plug into the expression, you will get. So this is the thing that we have it. Let's move to the next part of that one. So the next part is the D part that we have it. Briefly describe how the velocity diagram that you drew. So that is the velocity time graph that we had drawn in the A second, either or not consistent with the flowing. So that is the A second part that we have drawn. So basically A second part, that is the here we find it out the basically at the velocity direction. They mean to say that the diagram or the velocity direction that we shown it at this, is it that is resemble, so that is resemble with the diagram that you made it or not. So okay, is it that is consistent or not? The velocity v is a function of the t derived in the part b1. So that is the b1. Okay, so the b1, this is the velocity. So they mean to say that is it the velocity direction that we have find it out, the positive or negative, that is consistent with the expression that we have it or not. So basically this is both have to be come out to be positive. When you plug in the time value to that one, it should come out to be positive. And as you can see it also, even we had done this one, so even we had done this part at the t1, we plug in the value the t1, we plug in the value the t2, and both come out to be positive. And yes, so that is consistent. So basically that the both the positive, so this direction that they have shown it, that is come out to be the right, and we are correct regarding that one. Okay, now the next part of the question is the graph sketches. So you drawn this graph, is it that graph is also resemble with the time, so whatever that we have it, the above one, with the first, the velocity expression that is come out to be positive or not. So for that one, so this is the graph that we drawn it, and we have the t1 t2 time. So the t1 is p by 2, p by 2p by 2q. So basically p by 2q. So the p by 2q is somewhere here. So if I'm not wrong, p by 2q is exactly in the middle of that one. So this is come out to be, the velocity is come out to be positive at this point. So this is positive. Okay. And then the next one, the next point is 3p by 2q. 3p by 2q. So 3. So the next point is 3p by 2q. So 3p by 3, so it is 1.5. So basically 1.5 is come out to be here in the middle of that one. So again, you can see this one, it is again the velocity is come out to be positive, as you can see it. So this is also positive, this is also positive, both are positive. It means that the expression that we have it again consistent. So if you want to go more deep into that, so I will show you the solution once. Let me zoom in. If you want to study more about this, so this is the first part of the uh, D first part. This is the way that you can write it in a more detailed way, but they are asking, examiner is asking the brief only, so you can explain that way. So this is the second part, you can explain that one. So it is equal height and something, the position are, both the position are coming out to be positive, and that is consistent for that one. Thank you. Have a good day. So if you had the questions, so please leave it in the comment. Thank you.